Hello everybody, this is the video install for the drawing package in Fusion 360. This course is primarily for CAD/CAM, but we wanted to make sure that you knew how to make drawings from your models. You need to make reference drawings. So, in this tutorial we're going to be doing drawings of the Vise Stop Bar, Vise Stop Block, and Vise Stop Rod. These are models that you made early on in the semester, and you should have made them by reverse engineering the parts by measuring them. I will say that if you do have some features that are different than mine, that's okay. But the scope of this project is going to be to fully define the features you do have on your model with dimensions and drawing views. So we're going to start with the simplest of the three, which is the Vise Stop Rod. So let's go ahead and open that model. And we'll close the data panel. So my model, I have a radius here. It might be a different size than what you have. I have a radius here. If you don't have those features, don't worry about it. The intent is to learn how to take this model and make a multi-view drawing of it. So for the first thing we need to do is we're going to go from the design to the drawing workspace. And you want to select on from design, and that will be the active design you have in the model space. It's going to highlight it, and if you were doing an assembly you could select just certain components. In this case there aren't multiple components in this model. The sheet size is the size of the paper, and the smallest in drafting tends to be what's called a tabloid size on a printer, and it's 11 by 17. And then it goes up from there, B, C, D, E, larger and larger paper sizes. For the purposes of this class, we'll just select B and we'll go with that. This is only one part and it's not very big. So we'll select OK. And a new window should open up. And it's going to create a separate file, if you would. So you notice it says untitled at the moment. And you can see the model as I had it displayed. It's showing a view. So you want to place your first view, and then what will happen there is it sets the scale for the drawing. Now say you wanted to change the scale, you would update this number and make it 1:1, and it fits the page better. So I'm going to go with just visible edges without hidden lines. And then we're going to leave the rest of these at default and select OK. And it creates a line drawing of that particular view. Now this is what is called your primary view, your base view. All other views you make would be projected off of this view. So if we highlight the view itself, highlights this box around it, you can use drawing views. So we have the base view. You can do a projected view, so that you would have to have a base view first. There's what's called a section view, and that would be to cut the part in half. We'll do that on a different part. There's a detail view if you want to focus in on one specific detail, like if you really wanted to look at a smaller area here. Let's go with a projected view, and if you drag the cursor to different angles, it'll give you the different angles of projection. So if the first base view is what we would call the front view, this would be a top view, this would be a bottom view, this would be a right view, left view, and then an isometric. So to describe this part, I think it'd be advantageous to have a top view and a side view. And we'll go ahead and throw a three-dimensional view there. Then we hit the enter key and then it turns them into drawings. You can position them, but it keeps them in line with the primary view unless you break the link. So if you want to make a little more spacing around your previews you can do so. If you move the primary view, it's going to affect the your base view is going to affect your projected view positions. We'll leave it at this. It automatically puts in the name of whatever the model was. If you had a project, you could double click on this text here, and we could call this the large Vise Stop Assembly, abbreviated. And you can fill out the title block. It's already got me as drawing it. If you had a coworker check it, they could put their names in. If you generate a drawing number and your revision, typically I would start with 0 for prototype, and most companies use numbers for prototypes and lettered for production release. Okay, so you have your primary views. Now all we have to do is go and apply dimensions. We're going to apply a dimension that's a diameter to the outside of this side view. I'm 0.75, so it's 3/4 of an inch. But the precision is only a 2 decimal point. You have to exit the drawing dimension command, double click on the dimension, and you can change the precision, which will change its default tolerance. You also have options to put in different types of tolerance. You could put in a symmetrical, deviation, or a limit. Let's change this to a symmetrical, and it puts in 0.75 plus or minus 10, and you could change that to 0.05 for 5 thousandths. The next tool we're going to look at is this center mark. For centers of holes, like this hole here, you would want a center mark, perhaps at the center of the circle there. Gives you something to dimension to. Now let's put in some linear dimensions. We go back to the Smart Dimension tool, and let's put an overall length. So you start here, and select the second side, and pull up where you want to let the dimension lie. It's just like the sketch tools. And I generally start with the largest one first and work my way down. So a logical profile to see the dimension on is what you want to use. So let's stay in this view, and we'll dimension the distance to this hole, center to end. We want to assume that this threaded hole is on center of this entire cylinder. We can place a center line on the cylinder. Now let's dimension this view for our steps. So say we want to define the width of the 2 landings, and then define how long they are. You simply drag a dimension like this. Now this 1-inch dimension occurs in 2 places. So we can edit the dimension, and you would place your cursor outside of the arrow brackets, and we could type 2 times. So you know that dimension occurs in 2 places, here and here. Now I have a small radius down in the corner here, which also occurs 2 times. So we'll pull that dimension out, hit the escape button, double click on the dimension, and we'll say 2 times on that one as well. We haven't placed the dimension on where the position of this 1/2 inch is. So let's take that off center line. We'll draw a center line first. We'll drag the center line, it's all the way to the end of the part, and that'll allow us the dimension from center line to the edge a 1/4 inch dimension. Now it's best practice to make sure that these dimensions don't overlap, so you may have to do some adjustments so that style-wise they're very legible. Something like that makes it more clear which dimension is associated with which leader line. Okay, so we only have a few more features left. We've got a radius here. Looks like a 60 thou, and I believe the 60 thou is also over here. So what we can do is, in this case, say 60 thousandths and type the abbreviation TYP, which means typical. So that would mean all outside edges would have a typical 60 thousandths radius unless stated otherwise, like here. Okay, so now we're going to do the whole call out. So we're going to point at the thread, which is the largest feature out, and we're going to type that it's a 1/4 by 20 pitch thread, United National coarse thread, and it goes through. So the drafting abbreviation is like that. If you feel the need to have dual dimensions, you can select on a given dimension and edit that dimension by double clicking on it, and you can click alternate units and it'll throw the metric equivalent on that dimension. Now the next thing we need to do is put in titles. So you would put a title under your primary base view, and we're going to call this the Vise Stop Rod. Different companies have different standards for it. Last one I was working at, they always had it underlined and would put the individual view like that. Named that one, and it's going to be Vise Stop Rod, and we're going to call out what type it is, view it is. It's a 3D reference view. Okay. And we'll go ahead and underline that and make it center justified. Now there's no need to list the scale if everything's the same scale, but if you do have a view that differs from this sheet scale, you should call it out in the view as well. Okay, so I'm going to go around and I'm going to adjust some tolerances. For this 6, I'm going to increase the tolerance on that, make it plus or minus 3. Same thing with this one. 3 decimal points, and a 1/4 inch as well, and our 1/2 inch. We can leave the radiuses at that dimensions, and we'll go ahead and bump this one up to 3 as well. Okay, so if you have something that represents this, that finishes the first aspect of the assignment. You're going to save it. You probably want to go ahead and just go with the default name. It's Vise Stop Rod. Save it in your folder. And then you're going to output the PDF and upload your PDF in Canvas. Alright, that's it for the Vise Rod Stop drawing. Now we'll move on to the next one. Okay, we'll go ahead and close the Vise Rod. Go over to the data panel, and now we're going to pick up the Vise Stop bar. And once that model's open, we'll close the data panel. And we're going to switch our workspace to drawing again, and you're going to select from design. We'll select OK, keeping all that stuff at default. And we should pop up with the screen like we did last time. Now, for some reason, its scale went to 1:4. I think it's pretty small. So let's go to 1:1. This particular part's not that complicated. We're only going to need the 3 views to describe it. So we'll put our base view here and select OK. Then we're going to do projected views. Pick your base view. We'll do a top and a right side view. And then see if we can fit an ISO. That's looking a little big, but now the standard style was on hidden lines shown, so we're going to change that. We're going to edit the views to be no hidden lines. This tends to be the trend these days. You used to see drawings with more hidden lines, but more modern drawings don't tend to have that. Okay, let's go through and let's put our whole center points on first. So you click the geometry center mark and go around to our circles, and we're going to put our center marks on them. Now we're probably looking at wanting a center line for that whole pattern here. Now let's put some dimensions on. So we'll start with, in this view, let's do a overall length, and we're at 9.46. We'll go ahead and put our diameter on the end here, and we'll dimension the bar in 2 places. Looks like we're going to run out of room, so we're going to go and modify this view, and we're going to change the scale. So we'll go from 1:1 to 1:2 to shrink down the isometric, and that'll allow us a little more room to work with. Yeah, we're going to drag a little more white space here because we need to have a dimension that goes from the edge of the part to the center of this whole pattern. So we'll go from the center line to the edge of part, which should give us the location of the hole in that axis, and then we can go from the end of part to the center of the first hole, and then from end of part to the second hole, and then end of part to the third hole, and then end of part to the shoulder. I'm going to do some adjustment to create a little more white space between the different views. There we go. Now we need to call our hole diameter. And I think we'll place our hole call out here. So that's the diameter of our hole, but we have it occurring in 3 places. So we're going to go 3x for 3 times. We have a radius on the end here. It's probably 60 thou if it matches the other part. And on the opposite end there's a chamfer. Now there's a couple ways to dimension that. It doesn't look like they have a chamfer call out in this software. But you could call it out with 2 dimensions, so this would be 0.2 by 0.2. Or you can do what's called a chamfer call out, where you point at it, and we're going to say that it's a 0.02 by 0.02 by 45. And we'll insert the degree symbol. Okay, so, and we need to modify this to say through. And the only other thing we don't have defined is this angle here. So we need to put an angular dimension. Which we could do that, 135. Probably cleaner way to do that as a 45 degree angle, but we'll let that be. I'm going to make a little more white space between the 2 views because there's a lot of dimensions in the front view. And we're going to give the okay, so now we just have to name our views, and we're going to update our title. It's for the large Vise Stop assembly. It's the Vise Stop bar, and we're going to put in our title here. Bar. Like be consistent with our other drawings, we'll make that underlined. We're going to put a title under our isometric. Vise Stop Bar. And we're going to hit enter. We're going to call that a 3D reference view. And we're going to put a scale of 1 to 2. Stretch that out. I get center justified for the whole thing. Alright, so that's your second drawing. Now let's move on to the third one. We're going to hit save. We're going to leave it as a Vise Stop bar as its name. Hit save. And again, you're going to need to output a PDF and upload that on the assignment. Okay, so we're going to close the Vise bar. And now all we have left is, of this series, the part with the most features on it. And so we have the Vise block open, Vise Stop block. Go to drawing, from design, select the default. And 1 to 1 looks pretty good scale for this one. So we're going to do a top view. And we're going to select hidden line only, hit OK. And we're going to highlight the view, and we're going to project a top view, and we'll go ahead and go with a right side view in this case, and we'll put an isometric way over there. Okay, let's start with our center points. So we're going to put one here and one here, and one holes here. We need a couple more views. Okay, so we have a threaded hole on one side, but we need to project a bottom view to show this counterbore side. Okay, so let's spread these views apart. We're likely to have quite a few dimensions. So we have a front side, we have a top side, we have a bottom side, and a right side view. Okay, so let's start with our overall dimensions. And we're going to do as much of that as we can in this, what is the front view. We're going to go dimension. You have to zoom in, pick the two edges you want. I've got an even 3 by 1 inch. And we'll go ahead and dimension our slot in this view. We're going to stick a center line on the center of the part so that we can give a dimension from center line to one of the edges. We'll go ahead and modify this dimension to say typical. So all the slots will be that typical size. Now we're going to dimension from the center of the hole to edge of part. Okay, we have 3/4 of an inch. And we should probably put another center line down the middle of part just to make it clear that this whole pattern is on center line. And then we have a dimension from the center of the threaded hole to edge of part. We're going to call a diameter dimension on the large bore. We're going to modify that one to say 2 times through. Now here we have a counterbore feature. And what we're going to do to describe this is we're going to put in a section view. And we move the base views over because we're going to put a section view in here so that we can see what's going on cutting through these different holes here. it's a clarifying view. So we'll go to section view, and we click the view we want to slice, and we pick first spot for a location. Try to have it a vertical line, and select your second location and hit enter. And it's going to ask you where you're going to place the actual section view. So we'll put it here and press enter. Now our section view is not aligned with the center of the hole, which we do want. So after you create it, you can move it over and align it with the center. And it'll go ahead and update the view over here on the left. So we're showing a slice through the clearance hole side with the countersink, with the threaded hole on the far side, and the slot that is interrupted in between the two. First thing we're going to do in this view is we're going to put in center line, and we're going to extend that to go all the way across. Now we're going to call out the threaded hole since it's fairly simple in this top view. So we'll just go with a note leader line, and we're going to call it a 10. I believe it was a 1028 UNC. It goes through one wall. Okay, here on this feature, we're just going to go ahead and dimension it. So we're going, the width here is 0.35, but we're going to add a diameter symbol. And we're going to call that typical. Now we'll go ahead and dimension our counterbore head depth from there to there. .19. Now we can go ahead and we could call out this hole like we did in this dimension, or we can do it as a whole call out over here. So we have a 200 thousandths, it's probably a 201 diameter clearance, and that one also occurs 2 times, and it's through one wall. Okay, that's pretty much it, except for maybe a general edge break note, which you could put down here. You could have a note that says 0 to 0.01 edge break typical. Let's just call it a 10 thousandths edge break. Okay, and we're going to change the title on this to be Vise Stop Assembly is the project. Alright, we'll set our rev 0. And we need view titles. Okay, there we go. If you feel like you've got all the dimensions represented, probably want to increase the tolerance, default tolerance on some of these. Okay, when you're all done, it should look something like this. Again, I'm not going to be real picky on the dimensioning. As long as you have enough, the same number of views that I have in this file, font sizes and such, all those drafting standards that if you want to go into the DES department, they can beat you up about it. The intentions is just to give you a base knowledge so you could make a drawing in Fusion 360, and if you choose to learn more, the DES program is quite good at this school for teaching drafting. All right, again, this will be your third submission for the drawing assignment.